Okay, welcome to TechTip 74, where Nigel and I are going to talk about shore power isolation on boats.
And grounding.
And grounding. So this is put together for boat how-to, for all of your advanced electrical stuff. We're going to talk about this, and for technicians. So Michael Beamer here, Skagit Valley College. A lot of the viewers know us already, but some of the new boat how-to people will see this, where we're training technicians. And I always get the question about this whole idea of isolation. And so Nigel, you want to tell us a little bit about why do we want to isolate our boat anyways?
Well, let's back up a little bit, Mike. The grounding connection from the AC shore power to the boat and within the boat is absolutely critical to safety. And over the years we've had a number of electrocutions both on boats and in the water around boats because of defective grounding systems. And effectively the green wire that's coming onto the boat from the dock on almost all of our boats has to be carried over onto the boat itself and tied to the boat's grounding system. But if we do that, we bring aboard a corrosion potential, which we're not going to discuss today, but
Sure.
Galvanic corrosion. So we've got a couple of ways of breaking that link that brings aboard the corrosion, and one is with the galvanic isolator, which I see you've got an old one here, chopped up.
Chopped up and very old.
Has 4 diodes in it, and nowadays this wouldn't pass any standard because it also requires a capacitor. And the other way is with the galvanic isolator. And both of those pieces of kit break that connection between the shore power grounding conductor and the boat grounding conductor, but enables it to be the safety features to be maintained
Right,
on the
so
boat.
it'll pass any AC faults, but
Well,
we're
not
really
not
looking for the DC,
the
right?
isolation transformer, of course, it just stops. The shore
Stops,
power
yeah.
stops at the isolation transformer and starts again on the other side of the transformer. This one, it comes through the grounding conductor, but it breaks the galvanic circuit.
The galvanic circuit, which is all really low DC voltage.
Right.
And they used to call them zinc savers, right? Because that was the idea where you'd preserve your anodes.
Yep.
And so technicians, someone taking a course in electrical, the hard part is when you come down to a boat then is you could have just a safe green grounding conductor. Boat's safe, but your anodes might be protecting the boat next to you because the whole grid's tied together.
Right.
So that's why we talk about isolation issues. So we want to make sure it's safe. You first of all need to verify the integrity of the ground. And so we're going to talk about these 4 to 5 different scenarios that you would want to look for as a technician or a boat owner. So one is you have a safety conductor. The other is you've got some sort of a galvanic isolator in your circuit, which will preserve your anodes and keep you reasonably safe. And then the really one of the kind of the cream of the crop based on money and weight and time on a boat would be to have an isolation transformer.
Yeah.
Okay, so the question is from my technicians is how do I know? I come onto a 40-foot-ish boat and it's got a mumble jumble of wiring. How do I know if it has a safe ground path? How do I know if it has an isolator or an isolation transformer? And so I think we can explain that in about 10 minutes or less.
We'll see.
Okay, I had to come back down to the lab. Nigel and I are having a good time, and we got a little bit boogered up there. You'll see that in the rest of the film, but it wasn't 10 minutes, it was 20 minutes, and we had the issues. So going to do this real quick for those of you that want to do this. And Nigel and I had a great purpose. I'll tell you what we found on my own boat that needed to modify this quick reference guide. And so the quick reference guide has the step-by-step. So I'm going to try and tell you in about 3 minutes what we were demonstrating down there on the boat. And this is one of the labs that I have set up with students. Future technicians have to be able to do this. And so there's really just a few things that we're trying to find out on a shore power cord into a boat. Is it just safe and does it work, but is the boat not protected, isolated from the rest of the grid, which is fine. I mean, you want protection, but the other thing is, does it have a galvanic isolator? This one doesn't meet standard like the one that we had down there, but does it have a galvanic isolator, or does it have one of these big old isolation transformers? And how does it go? So pretty simple test that we're looking for is if you study these transformers a little bit, different lesson, but they're essentially a couple of coils of wires, and they are not physically connected, but they can pass electricity into your boat. And so this is the ideal. You make your boat your own island and it's protected. So what do? You have your multimeter, you have it set on continuity, so boat how-to and scallywag technicians proficient with that. You bring the cord in the boat, and we're just looking for a couple of different things. And those two things are, does the green wire beep, yes, have continuity, or does the green wire not have continuity? And then the secondary test is we can check our black and our white wires and see, do they have continuity? In this case, they don't. Another scenario over here, they should have. And so, easy enough. What is that telling us? Okay, the scenarios. If you have continuity on black, white, green, then the boat is safe. It's wired traditionally, has no isolation. Boom, check that box. Now depending on your meter, we talked about it, you gotta know how to do a diode test. If you're getting not a beep, not 0 ohms resistance, but something else, chances are it's got a galvanic isolator. So you check the green wire and see, depending on the meter, if it's voltage drop or how your meter works, boom, you can say, yes, it has a galvanic isolator. Get into the third test, and we're looking for, okay, we don't have continuity on the green wire. Step A, check the white and black. If you have continuity on white and black but not green, that vessel is very unsafe, and you've got to get that fixed straight away. And so if we don't have continuity on any of the conductors, well, actually, if you don't have continuity on white, black, but you do have green, that means it has a transformer, and they're using it for polarization, for correct polarity, not for isolation. And so that really doesn't make any sense if you're carrying around the money, the weight, the space. You want to have that green wire not connected. So if you have the open greens and the white and the black, then you can go, okay, this is, the boat has a transformer, it has a source of power, and you make a cursory check and make sure that the white and the greens are hooked together, because this is a source of power, and that's what ABYC says. So those are the tests. If you're isolated or not, 1, 2, 3, follow a quick reference guide and you can go through those. The caveat, what boogered us up, is you need to have the outlet that you're testing. So this is my shore power side. I bring the cable, the shore power cable, into the boat, and I'm testing an outlet on the boat. It has to be non-inverted in the modern world. And that's because, this is what I ran into, recently we upgraded my boat with a new Victron Multi Plus. And so I haven't checked all the other inverters, but when you have an inverter boat now, the Multi Plus and the Quattros, all of your shore power goes through the inverter. So when you power down your inverter, in order to do this testing that we talked about, you're gonna get mixed results. So if your boat has an inverter, you need to check at the inverter input to do these tests. So you're gonna be down in the engine space, you're gonna pop the cover off of your inverter, and so the idea is we need something that's not through an inverter in order to discover what we have for shore power isolation. So it's fun. You can watch the rest of the video with Nigel and I kicking around, discovering that on my boat, and we'll go through this test again and hopefully it makes sense. Pop down here, look at cruiserscollege.org, and you can download not only the quick reference guide for shore power isolation, but about 4 or 5 other things. So let's get back to the video with Nigel.
First thing you want to do is, the way we're going to do this is we're talking about a connection between the power pylon on the dock and the boat itself. So one thing we need is the connection that goes out there. And bringing the shore cord on board the boat is a good way to do it. But before you go and disconnect the shore cord, the other thing is you need a working outlet. And so working is the key. You want to make sure that it's turned on because of the last test where we're looking at the isolation transformer. So we're going to power up a circuit. This circuit right here is working. I've plugged in my little electrical tester and it shows that we have power available. It shows we don't have reverse polarity, and it shows that we have a ground of some sort, no faults. So we're going to start with that. So let's go get the shore cord and do some investigation. Show them how easy this is.
Well, let's hope so, okay?
All right, here we are.
We're at the dockside pedestal and we're about to unplug the short cord and we're going to bring it on board the boat. So, something to note is that the ABYC, and I can't remember whether the ISO does as well, it requires there be some kind of locking mechanism at both ends of a short cord, and you often see that violated.
So when the wind blows, it doesn't come unplugged? That
Yeah.
doesn't count, that little loop around the water
Well,
pedestal?
This one, no, that doesn't count. We've got these twists in, these plugs, so there is a little bit of a lock there, but it would be way better if there was some kind of a locking ring on there, which there isn't.
And of course, whenever you're unplugging short power, you have the circuit breaker shut off.
There's a circuit breaker in here, Mike?
Yeah.
So in terms of plugging and unplugging, when you're unplugging, you always unplug from the dock first. So now the cable is not live.
I believe in your awesome textbook that my students buy, you have a whole procedure about that.
Yeah, well also,
Outline?
actually, technically speaking, Mike, you're supposed to have a label on your boat that says this as well. And then when you're plugging in,
I thought it was a dead giveaway.
right? So when you plug into the boat first. So again, when you take the cable ashore, it's not live, and then you plug in. And then when you unplug from the dock first. So once again, it's not live. So if we drop it in the water in either direction, we're not going to put anything into the water.
Okay, well that was mostly successful. We brought the cord inside.
And before we go any further, a couple of things. If you look really closely, you'll see there's a little burn mark on this pin here.
Yeah.
And you should look really closely at your short power cord on a regular basis at both ends, and also the inlet and the outlet at both ends. And if there's any signs of burning, you shouldn't plug in. Now, I probably created that little burn mark because I unplugged this without turning off the breaker.
Oh.
So I expected arc when I did that. So now you're going to have to clean this up before you put this thing back together again. But this is really important because we get quite a number of electrical fires from corroded pins and burned pins, one or other end of the short cord.
Short cord. Yeah, we actually did a little tech tip about hot hull inlets where we took and dissected some of these and showed how that little friction connection. It's not the perfect connection, but it's what we got. So.
Yeah, it's what we've got. And the problem is in our houses, all of the main connections are bolted, but obviously you can't bolt a short power cord. So we have this pin and sleeve connection. The other thing to note here is the grounding pin is the one with the bend on it.
Yep, got the bend.
But also, before we start fooling around with any of this, we need to make sure there are no other AC sources on the boat.
Correct.
Like a generator with an auto start or an inverter. We disable all of the stuff.
Disable equipment, and then we generally like to, all of our technicians carry a little voltage sensor. Pretty inexpensive, and you can just go around your outlets and wherever. Oh, why the heck is that getting? Well, we have to shut the inverter off. We have to follow our own advice.
Should do. Would be a good idea.
Should do. So we'll get the inverter shut off, and then we'll get some testing going. Okay, so we're following our own advice. We had a little bit of live. We shut the inverter off, and so now I'm going to test again. And sure enough, it's safe that we can work on the system and check it out. You know, we call the inverter the silent killer and stuff.
Yeah.
So safety is the number one thing, whether when you're learning about electricity. So
if this was a boat with no isolation transformer and no galvanic isolator, this pin here should be hardwired through the boat's wiring, the grounding pin, to the grounding socket, every grounding socket on the boat. So we should be able to put a meter in its ohms resistance mode. We should be able to put it between the grounding pin and the grounding socket on any outlet, and we should read a very low resistance.
okay.
Ideally below 1 ohm.
Below 1 ohm.
What you've done here, Mike, I see, is you've actually pulled out a cable from the outlet and you've got the grounding cable.
Just the green wire is all we're interested in.
So we can make it really easy. So you want to put the meter across those two? We're going to put it in ohms mode.
Ohms mode, and this isn't a class on multimeter use. You know, there's other places to get that information, but we've got this. I'll turn on the beep. So we get a beep if it's low resistance.
So with an ohms meter, you want to test the meter between every single test, because there's a fuse in the meter and it's very easy to blow it. And if you blow it, and you then spend the next 8 hours troubleshooting, and you've blown the fuse. You've just wasted 8 hours.
And for technicians, we like to work, if you can, with a jumper wire in one hand. It's safer. It's easier to do to make sure you get accurate results. So I check meters working,
Right.
and I go to ground, and this is an open circuit.
We're not getting. There's no circuit.
No circuit.
So we've got 2 or 3 possibilities. One here is that we have an isolation transformer, because that's a piece of kit that's specifically designed to break this circuit.
Right. Or we could have a potentially very unsafe boat. Some of the old fishermen used to just cut the green wires.
Yeah. Yep.
Which is a terrible way to have a boat.
Or we could have a galvanic isolator, because sometimes you get very confusing readings off a galvanic isolator, because the galvanic isolator has a couple of pieces of kit called a diode.
Little blocking diodes.
2 in one direction, 2 in the other. And some meters just in ohms mode, they really do produce confusing readings with them. So then you really want a diode tester.
A diode tester and go through. So the reason I think that this test is brilliant is we can, if we were to start crawling through this boat looking for one of these gadgets or a transformer, we may or may not find it. At the current rate of about $2 a minute for a technician's time, you want to be right here by the door if the owner's watching, and in 5 minutes tell them that you have one of these or you don't.
So the way we would find that, we'd put our meter into diode test mode, and then we'd run the same test, and then we'd reverse the meter leads. And depending on whether we've set the meter to read resistance or voltage drop, and we won't get into why, but those are the 2 options. We're going to get a similar resistance reading in both directions, or a similar voltage drop reading of about 1 volt or so in both directions. And then we know we have a galvanic isolator in the circuit, so we know we have an intact grounding circuit with a galvanic isolator in it.
Correct. Now I'm going to give a plug out not only to your website, because not everybody can come to Washington State and get training, so that's a good source, but in the Boat Owner's Mechanical and Electrical Manual that you've created, my technicians use this. I have to refer to it sometimes. If you just pop in page 190, there's a whole write-up on how to test galvanic isolators. So we're just giving it and you should be proficient as a technician, or if you're a boat owner and want to know if you have a galvanic isolator, let's just pop in and do it. Okay, so use the book. You got to have it on board.
At this point, we've got no shorter boat grounding circuit.
Correct, and no galvanic isolator.
We have a galvanic isolator, although we don't have a meter with a diode tester at the moment.
But
that doesn't look like
the other thing that we try to tell technicians is, if this thing is installed properly and you're looking for a galvanic isolator, the best place to check is just inside of that hull inlet. That is typically where most boat manufacturers and technicians are going to install that.
Well, it's where it's required to be installed by the ABYC.
It is required by ABYC to install it there. So save yourself some time, find out where this short cord came into the vessel, and look immediately there for some type
incidentally, if you find one like this, that's a Zinc Saver 2. These are for many years now,
decades
complied
ago.
with the ABYC standard. You need a galvanic isolator which has a label that says it complies with ABYC, whatever the standard
A28.
is. Thank you. And also that says it's fail-safe.
Fail-safe, yes. So if we were to get a lightning strike that might potentially damage this piece of equipment, it's going to fail back to where we've got a path for AC safety. You will no longer have your galvanic isolation from your neighbor, but you will still be safe and hopefully not hurt people.
Yes.
That's the underlying thing with our safety standards.
So right now we either have an isolation transformer, or we have an illegal, or basically an unsafe
boat
setup with no ground connection from shore to the boat.
So before you run and tell the boat owner or your yard supervisor or somebody, or get worried that your boat's unsafe, we're going to look for an isolation transformer. Okay, and so in order to do that, what you're going to do then is, if you have an isolation transformer, we need to know if there's a path on the hot wire. Because we know this outlet was working. So somehow from the power pedestal to here, we had a connection. So an isolation transformer in a 30-second elevator pitch is a couple big coils of wire that actually transfer the energy with no electrical connection. So if the boat has the transformer somewhere on board, we can figure that out by doing our same continuity test on the black wire. Okay, now when we go to pick up the hot wire,
So now let's remember now, this is the hot wire. This is why it's essential to make sure that everything is disconnected and there's no AC
correct,
source.
no path. But I like to use some sort of a voltage tester. I got a couple of different models here because you can plug your multimeter into, they got these little test tabs. Because when you're trying to get into a duplex receptacle, you don't know for sure if you actually have the connection or not on the black wire. And by the way, if you don't know which pins are which, here we go, another plug for Nigel's book. It's got everything in here with which is the hot, in both receptacles and short
I made
cords.
it easy now because I burned a little mark
We
on
burned
this,
a
so
little
you can
mark
find
on
it.
that one, so that's pretty good. And so
That's not the recommended way to do
that
it.
is not recommended. So we plug in one of our leads over here. We're doing a continuity test again, so we're going to make sure our meter is, it's still beeping. And then
So we've got, this one is plugged into the boat's hot wire.
on the
This is
inside of the boat,
The hot wire from the short cord, which is coming, if there is a transformer, will be coming in on the other side of the transformer.
correct. And so if I do this and get a path, then we have an unsafe boat.
Right.
If there's a direct connection through the cord into the boat for hot, but not for ground, it would be unsafe. This one has no connections at all. And we know that this boat has an isolation transformer.
Yeah, because it was working. So
Because we had power at the outlet, we unplugged, it went away.
Right, and there is no path between these pins. So we know there's an isolation transformer.
Right.
Yeah.
One other check that you should do if it has an isolation transformer is to make sure that you have a neutral ground connection
On the boat.
on the boat.
Yes.
Because once you become your own source of energy, we have to have a path back to ground. And so that's something we could check right here. If we know it has a transformer, it's going to take less than a minute. Let's make sure that it was installed properly.
Yep.
You need to check it inside of the boat. Let me get down here. Got to be careful when we're making these videos.
Right.
We want to make sure that between ground pin here and neutral that we have a connection. So let me get my ground pin again here. So now we have our ground pin and our neutral, and edit that out. Why are we not having a, how does it not have a neutral ground connection?
Shove it in. Well, you know, but this, from a teaching point of view, this is great.
Yeah.
Yeah, because we've just done the test and discovered that we don't have a neutral to ground connection.
Yeah. No, I mean that.
So I don't think we want to necessarily edit all that out. I mean, maybe
maybe
our response would be great in the video, and when you look at it, you'll have to have a look and see.
No, I will. I mean, it's okay.
Well, we found a missing neutral to ground connection, so we've rectified that, and now we're testing to make sure that we've rectified it.
There we go.
So that was interesting.
So it's simple. Bring the cord inside a working outlet and run through 3 or 4 test scenarios, and you can find out, is it safe? Is it not safe? Does it have a galvanic isolator? Does it have an isolation transformer?
Yeah.
And they're gonna think you're brilliant.
Here's another test. If there's no isolation transformer, then we're going to find that the grounding pin is wired to the grounding circuit on the boat, which it should be.
Should be.
But we also want to know if it's wired to the water, to the boat's common grounding point. So you can put your meter in ohms mode on the grounding pin here, and then you can stick it on the engine block or
Down on the engine block, DC negative,
DC
and
negative,
see if it's connected.
and it should be connected. And if it's not connected, then your AC system isn't grounded to the boat's common ground point,
which is not safe and not compliant.
safe. And it needs to be grounded to the boat's common ground point. If it's not, and you ground it, you then need to put in an isolation transformer or a galvanic isolator, because otherwise you're going to bring corrosion on the boat.
On the boat.
So
that's
a lot to take in.
That's a lot to take in, and actually what we've created for our technicians, because you go through training and then 6 months later you go onto a boat, you might forget. We have a quick reference guide that'll be in the show notes, and we'll link it maybe on Boat How To. So you can look at the quick reference guide after you go through a course and you actually get down in your own boat or a customer's boat and be able to go through the checklist. So we'll provide that for them. You got other
It's
things?
worth
Yeah.
noting on that for many years the ISO standards in Europe permitted that connection to be left off the boat as long as there was something called a residual current device, an RCD.
Like our ELCIs here in the States.
ELCIs. And a lot of the European boat builders still don't put that link in because they think they don't have to, but the ISO standard was changed in 2014 to where they have to have that connection from the AC grounding side to the boat's grounding
System. It's always important to know the standards.
Yeah.
If you're doing any electrical work or any electrical testing. So it's great. All right. Well, thanks for watching, everyone. Stay tuned. We'll keep putting out more videos. We
Thank
like
you,
to
Mike.
share the knowledge. So thanks, Nigel.